Hello and welcome back to a new video here on the Lötwig Fusel channel. Now in today's video we want to implement inversion of control for our boundless 2D game engine. Now in the last video we made our build system at a stage where we have everything that we need available inside of our Visual Studio solution. However, not in a state so that we can really do and write production modules without having to do manual fiddling. We want to get there, but we're not going to get there in today's video. In today's video, we want to implement inversion of control, and I could quickly open up my my slides again so that we have a bit of an insights of what we want to do today. So we talked about gluing and igniting. But what I really want to take a look at is I want to take a look at this structure, and I want to now move us to implement the structure by hopping through these three slides and implementing them step by step. The first thing is an interface. So let's actually just start designing this from the other way around. We're going to start by defining an interface and an implementation to get started. And actually, we don't really have a package now for our interfaces. So BL2D common is the package where everything is in here. So BL2D common, and what I want to have is I want to have something called API, which is basically our API of the engine. So it's going to go our whole engine API is going to be in here for all of our implementations. And this is a special project because it's not a library, it's actually going to be a headers project. So BL2D headers API. That's the only thing that we need in here. So this is kind of like interface definitions. And what I actually want to do is, and this is now where we're going to start up with our custom custom gluing of include passes and stuff like that. Inside of this API directory, I want to actually have directories for each API sets. So I'm gonna have a BL2D.dummy API set. So I'm gonna have a folder here. Maybe I want to call this like iBL2D. Maybe iBL2D is a bit better, or BL2D.I.dummy. I don't know how I want to call that. Or maybe just I2D, interface 2D, or IBLD. Because I want to kind of like, I think maybe let's call it I.BL2D.dummy. This is, I think, a good naming conventions. It looks a bit ugly, but I think that it's maybe a good idea. And inside of that folder, I'm going to have my idummy.h interface. Let's quickly add the structure here, and so that we have it in Visual Studio, let's initialize the projects once more. So let's reload it in here. So now we have the API set in common. We have the dummy application, and we have the dummy module. So now you can see that we have an API. And we have inside of that API, we have that iDummy. So let's start with a pragma once here. Let's add a namespace. Maybe I should zoom in even through. I already have the whole screen zoomed in, but maybe let's make it a bit bigger for YouTube. So BL2D is the namespace, and then I'm gonna call this class like iDummy. And I mean, it would be maybe better to have it inside of the dummy package as well. So BL2D dummy class iDummy. And if we are writing an interface, we want to have a default virtual constructor. And I want to say a virtual void say hello. So I want to have a function to say hello. That's the idea of our interface that we're going to define. So the iDummy, say hello, is what we want to do. And what we want to do is we want to now include that inside of here. So I want to now include the API. Now if I want to include the API currently, I need to go to like app, or actually not even app, BL2D, common, API dummy. This is the current include path. However, since the API names are actually explicit, so it's actually an iBL2D.dummy, which is kind of like a replacement for that path, I actually want to have custom include set up so that we can have a bit easier access to these. Now, how can we make this include path better? Well, we basically need to modify how our project system works. So inside of our scripts, boundless2d.lua, in our basic project setup, I want to have another include path. So custom include path. So include paths in Premic 5 are set it up like include directories. I want to steal this quickly from here so that we can see what's going on. And what I basically want to do is I want to hard code the folder in here. So we're going to go to the source folder. This is already configured. So I am going to do it like that. Source folder is there a slash already configured? Mox.lua? No, it's not. So let's configure it. So we have a slash, and then I want to include BL2D common API. This is one include path. Actually, I'm already going to add another include path in here, and well, you already guessed it. Our modules are also very explicit. In our modules, we have bl2d.dummy, so I also want to be able to include the module without any problems. So bl2d modules shall also be one of our include passes that are set it up automatically here inside of the project that we don't need to explicitly define. So if we are rerunning that and reloading that, we shall be now able to basically remove all of that and directly access the iBL2D dummy iDummy interface. And what I now want to basically do inside of that code base is I want to have a BL2D dummy iDummy pointer or reference and say my dummy. That's basically what I want to have, and of course this doesn't work currently, so maybe let's make it a pointer so that we can set it to something. That's basically the code that we want to arrange. We want to be able to get this iDummy from the IoC inversion of control container without knowing the BL2D dummy implementation, which is actually a good idea to quickly implement this in here. So we have the iDummy. So let's maybe delete that file here, and let's maybe add a new item. Let's call that one dummy.h, and let's go inside of that, and let's include the i.bl2d dummy.idummy.h, and then let's say namespace bl2d bl2d dummy is my package, and I have my class dummy in here, which is a public iDummy. And then what I want to do is, of course, I want to implement that. Let's quickly start by adding a new file, creating a file in here. Interesting. Location dummy.cpp. Yeah, probably because it at some point already existed. I don't know. So let's create a dummy.cpp. And let's implement the virtual method. And boom, let's do it like that. So we have the say hello, and we have the call in here. So let's now do some conditional stuff. If def bl2d, what do we have? Debug OS Windows. We don't even have the actual defines that I'm looking for because I haven't defined them yet. Actually, on console and on like console and non-console, I do actually also want to have defines. So let's define a BL2D thing. Actually, I'm always working with this macro prefix, so actually let me steal the prefix from here as well, because it's good practice. If we change the prefix, it's going to change everywhere. So prefix, and we're going to append to that prefix, I'm going to say console app, and I can copy the whole line. I need to learn the VS Code shortkeys. I don't know them. I only know the proper Visual Studio ones. Which you could probably also configure VS Code to use the same ones, right? But I'm too lazy. Console app and windowed app. Windowed app and console app. And if I now rerun that, I can write some conditional code for these different configurations to say in different ways hello. So let's discard these and let's reload all. And what I can do is hashtag ifdef bl2d console app. BL2D con. I mean, it's probably not have loaded these yet, but this is defined. Console app. Hashtag andif. Hashtag ifdef. BL2D windowed app. And this is actually then if I'm on a console IO stream, and if I am on a windowed app, I am going to quickly and dirty include windows.h, And depending on these implementations, I'm going to say hello in multiple ways. You might already have guessed how I want to do it. STTC out, hello world. Oh, come on, world. There we go. std end line. And then instead of here, message box W, or I can also do a message box A. Really doesn't matter. Now pointer. No, I'm now A. MB OK. Hello world. And hello world. And now you can see it's currently a bit problematic, but if I build that, it should probably work. Dummy.lib succeeded, so you can see it compiled fine. So the include was there. And if I switch it to development, it should also build fine. Yeah, it also built fine with these different functions. I don't know. Do I need to scroll up again or close it or rescan the solution? Maybe rescan the solution is a good idea. Rescan solution so that we might get the definitions of the macros as well. Rescan solution finished? Not finished? I don't know. Normally it should. I think this is actually, I mean, if they are not defined, it's actually not good because windowed app, I think did I mistype that? Yeah, I did mistype that. But we could be able to see them in here. I don't know why it's a bit delayed currently. C++ preprocessor. If I open this up, you can see that there are a ton of things defined. And actually, it's not defined. Why is it not defined? I have it in here. Macro prefix, I did run that. Huh. Somehow it did not define this. Maybe we need to restart Visual Studio. Oh, yeah, I know what's the problem. I'm an idiot. It is only defining this for applications, which is of course correct. But I also want to have it everywhere else. So actually this is cannot go in here. This need to go into the basic setup. Project type. This need to go in here, and instead of defining console and window, I do the defines. And now this should work, I think, also in all projects. Now I always know, even in the modules, if the application that's going to consume that module is going to be, yeah, okay. Now we are going. I was a bit confused there. Okay. If I switch to console, it should also switch to console here. Any second? This is sometimes a bit odd. Why are you still on windowed? Because of the include path, could be. Let's see. But there it is, console app. I mean, this is a bit odd because Visual Studio is sometimes a bit problematic with these defines. As soon as the project settles, it's gonna settle at some point. But okay, basically what we now have defined is we have defined an implementation of the dummy interface. Now our engine is flexible enough currently to also allow a dynamic initialized one, explicitly initialized one to the new dummy. So what I could say is this is a new. Yeah, let's do it with new currently. This is a new BL2D dummy dummy. This is possible. And then we can say dummy, say hello. And now on debug, I want to get some console message. This should work, right? This is the good old classical way. And we want to then make it the IoC way, right? We get a hello world and then we get that. And if we are on development, of course it's not going to work because our main function is then not going to be defined if I start that. Yeah, there we go. No main function defined. But we could quickly patch the... we need to patch this in later. Let's stay on debug for now. But in general, you would get the message box there, conditionally compiled. But But we can see this as soon as we're getting this working. I mean, we are still on the infrastructure and startup of the engine, so it's okay to do it like that. But what we want to do now is we want to implement our IoC container, right? Now, what was the goal? Now we have an interface and an implementation. That's good. And now what we need to do is we need to implement inversion of control. So we're gonna have two concepts. We're gonna have IoC registrations and IoC stacks. Let's start with the IoC registrations. The IoC registrations has descriptors of the implementation size and a factory and a deleter. We could do this maybe with. Actually, think we might actually want to do this either with unique pointer or with shared pointer. I'm not quite sure if I really want to have a shared pointer, because shared pointer would kind of like violate my concept of a stack, but would make our engine a bit safer. Not quite sure if we can really check a shared pointer or if we might gonna implement our own shared pointer function in the future just for these IoC stuff, which might be beneficial. Or we just gonna work with references, which would be rather what I would prefer. And if we have references and we have a bit of assertions, then on how our engine works, we should be able to write good code. I watched the talk of the creator of C++ on safe programming, and basically you should always avoid dealing with our own pointers. But we are on a game engine, and I do have the feeling that it's beneficial to implement custom stuff in here, just for the sake of also having a clean concept on how stuff works. And I think we want to do it. If we're going to have a problem in the future, right? Like, the problem with all of these, like, shared and unique pointers are a different story, but like the problem with shared pointers is a bit that if you require shared pointers, if you're using shared pointers, to make your life easier, it's good. But if you're using shared pointers because you need to use shared pointers because any other implementations didn't work, then you have a problem with your fundamental knowledge and usage of memory management. And that's kind of like the thing here. I have like these IoC stacks, and we have a well-defined lifetime of these. We have a well-defined lifetimes of an IoC stack. The first IoC stack has a well-defined lifetime of the application, right? The stack is initialized, then the application runs. The stack is going to be constructed as the application runs, and then as the application returns, the stack is in one order deconstructed, right? I mean, it would be maybe good if it deconstructs itself, but that's not really the thing here, right? We have a well-defined dependency tree. If it might, some future is not well-defined, we might want to change how it works. But I think that it's beneficial to do an old implementation here, because we have well-defined object lifetimes. And if we are staying at these well-defined way of constructing and destructing our engine, it's more beneficial than using like shared pointer automatic cleanup and stuff like that, but having like a coupled and non-clean written system. That's the whole point of why we're probably going to implement this, how I imagine that and not with shared pointer. All right, so let's implement IoC registrations. Now, one big thing to understand, this IoC registrations is going to be a singleton in the IoC package. This is dynamically initialized the good old singleton way, a registration class, because everything is going to be routed over there. So let's add this. Let's add a header file, and let's call this one IoC registrations. I'm not quite sure how I want to prefix them. Like, normally you type it like that, so small o on IoC. I tend to capitalize these always. Or do I want to lowercase these? I mean, what does... Let's write it in the proper way, right? Let's call it IoC registrations. All right, so namespace BL2D. BL2D. Actually, this is common stuff, so everything that's common shall be globally in the BL2D namespace. IoC registrations. So we're going to have multiple IoC registrations. This is what this class is going to manage. IoC registrations. Create a file. And delete dummy.cpp because we don't need it anymore. Okay, so now we have IoC registrations.h, and each IoC registration is going to have one descriptor, and the descriptor should probably be named just IoC registration, so singular of that. So let's copy that name. Let's I think we might be able to create a file directly from here. IoC registrations.h .h. Now we have the file in here. I think if I have clicked it, I would have automatically get an include to that, but that's okay. BL2D, common, IoC registration. This is an explicit path to that because this is fine. This is not something that we're going to use always. Again, this IoC stuff, it's important that every like retrieval of a factory will result through that. But it's never something that you include as a customer or later on in the application. This is never something that you're going to include. This is always something that's going to be provided for you. A BL2D application is going to provide to you a IoC stack. A BL2D, or let's say a BL2D instance is going to provide to you an IoC registrations, and the context is going to provide a stack. So, yeah, we're gonna see how it goes, but in general, you're never gonna directly access them. That's the end of the story. Let's copy these over, and this is now gonna be a struct, and it's gonna be singular. So an IoC registration is a struct that is containing some stuff. So what is the registration gonna hold? It's gonna hold this. That's not what I wanted. The size of the implementation and a factory and a deleter. So what I want to do is I want to include a function for that, so that we can store these as std function pointers. So first of all, I need a size. Size t should be always available, right? So let's call of these like object size. So we have a size of the object, and then what I want to have is I want to quickly alias myself a. Now let's make it the direct using syntax because it's a struct. Using constructor, let's call it factory, and let's call it deleter. So factory and deleter, they are both gonna be an std function, and like that, and they are both. The factory is gonna return a void pointer. Of course, this is a typed pointer. Actually, no, it's a factory. They are always gonna return void. They are always gonna get a instance as a void pointer, and that's actually it. That's the only thing that we need for the factory, right? Factory and deleter are the same actually. The factory is gonna get a pointer, and the deleter is gonna get a pointer. And that's it. The deleter shall not release memory. Maybe we should still call them like, let's maybe call them ctor and dtor of the object. So constructor and destructor. It's not typed, but this should not be a problem, right? Because the we're gonna kind of like generate some bootstrap code around these that is gonna later on convert these. You're gonna see this. And dtor. So that's kind of like the idea, right? We have a size of the object that we require as the registration to know how many bytes we need to allocate for the implementation. Then we can call the ctor, and then we can use the object, and as soon as it gets deleted, we can call the dtor. And that's the only thing really that we need to do. But actually, is it an IoC registration? It's kind of like an IoC registration. Yeah, it's actually an registration, right? That's actually good. Now inside of here, we need to manage these registrations. I am gonna register these in a unordered map because we're gonna have a key to retrieve a implementation, and we are going to have a registration itself, which is the descriptor. So actually our IoC registrations are gonna be built up in a certain way. If you're taking a look at these, you can see, give me the singleton of iRender context for D3D12. So a descriptor in the registrations is always associated with a interface and a name. So how do I want to enable up lookups? I want to enable lookups in multiple ways. Actually, what I want to be able to is I want to be able to have lookups via the API and then via the name. That's the general idea. So how can I do that? Well, basically, I'm going to have two nested maps. So actually, unordered map. We're going to have an unordered map that brings us an API to a unordered map of std strings for the name, and then an IoC registration. So for that we need string, we need type index, so that we can reference an API. Index, type, info, no, index. Type index. Why do I not have what? Is that like that? Oh, okay. Type index. So, I mean, yeah, okay. So we have basically, first we have a, let's call it registrations. Let's call it first so that I can explain it. So the idea is we have an unordered map that maps a type index to another unordered map that maps a std string to an IoC registration. And this is called my registrations. And this actually looks ugly. I never tried this formatting for an unordered map, but it doesn't look good. That's the idea, right? Type index is the API that we want to retrieve, and then we have an unordered map of strings and IoC registrations. Now, I'm gonna always have a fallback in here, which is basically an empty string. If you're providing an empty string, you're kind of like getting the default implementation. So that's kind of like a neat feature that we're going to implement so that we can kind of like fall back to something if we don't need a real name for that. We'll just take an empty string and that's good. So what operations does our IoC registrations container need to fulfill? So in general, these are all templated functions. We have a type name t that we want to retrieve. So what I want to have is I want to have a lookup function that gives us me a const IoC registration reference. That's what I want to look up. Maybe a pointer if we can't find it. I think a pointer here is fine if we can't find it, so it gives us null pointer. So what I want to call this function is basically just lookup. It's going to be const, it's not going to modify that. That's the basic syntax. This is the most simple case of this function, but we're also going to have a one that takes a std string view. We could do a string view. I mean, yeah, let's maybe do a string view here, even though we need to convert this at some point into a proper string so that we can get this. And this is going to be a implementation name. Now this function basically does nothing else than just redirecting to the other lookup function with t for the name as it is empty. That's the idea. It's a bit of a problem. We could make the registrations actually templatable, which might be beneficial. Okay, this is maybe this is a good idea. Let's maybe make this templatable, and instead of having a void, let's make a t-pointer in here for the interface. I mean, yeah, I mean, it still requires casting, but I think later on it makes the usage a bit simpler. It makes this function a bit more explicit on what it returns. And what we do in here is specifying void. And then we're doing nasty casting. Because actually, does it work? Or do we get problems with these? What do we get problems if we are changing how a function? Let's try it out. Maybe it breaks, maybe it doesn't break. I mean, the syntax is the same, right? We have 2 times a pointer, so it might work, or we might get a problem with the type stored in the function pointers. I'm not quite sure if this is defined. Maybe I don't know if this is defined. Let's keep it as is. I don't want to make too much experiments here in the video. We don't have too much time that we want to implement. I mean, it would be some nice aliasing to have this type, but I don't think that it's really necessary. It will also overcomplicate stuff. We do a simple like that. All right. So how do we do it inside of this lookup? Well, it's actually quite simple. What I want to do is I want to basically just search it. So basically auto iterator type. So the type iterator is going to be equal to mregistrations.find. So we're going to find something. Type ID of t. And this should look up the type ID, convert this to a type index right? And then we can search it up. And let's do a const registration pointer registration and set this to null pointer. That some point down here is returned. So if type not equal mRegistrations end. So now we are in here. Let's now call this one auto reference or const auto reference map 2. So the second map, which is dereferenced it type second. So now we basically have the second map that we can search. Then we can say it name equals mRegistrations find. No, actually not registrations, map2 dot find. And we now want to find for the name, which is probably not going to work because we need to marshal this in a city string in here so that we can find it. So if it name not equal map2 end. I know why it tries to give me a pointer there. What are you? Yeah, ty2. That's nice. But what is ty2? We could try and quickly provide a template argument. No, if idummy is there. bl2d dummy idummy. Not in scope here, so it can't find it as it seems. Yeah, I don't care. But it tried to? Oh, come on. I hope it works like that. Okay. So what we then can do is we can basically say registrations equal it name second. We could have also think use it like that. It's a bit cleaner. So pointer to that, and then we have an interface available. What I want to quickly do here is I want to have like an auto ptr equals. No, actually what I want to do is I want to have this stays as it is. What I kind of like wanted to do is I wanted to have a fallback here, right? If this fails and the name is specified, can I check if this is empty actually? Yeah. So if not registration and the name is not empty, so if we don't specify an empty string and if we don't have a registration, we could try searching for the default one. No, I don't think that's a good idea. I don't think that's a good idea because we have explicitly specified a name, so we don't want to have the default one. Alright, so this shall conclude our lookup functions. This is good. So now what I also want to have is I want to have a way of registering these. Now how can I register these? Registering is actually quite interesting. So I want to have a const void register. Now registering goes for a type name name t. So we have a type that we want to register for. And when we are registering a simple type like that, it's actually just going to be simple. Or actually, I want to have a type name API and a type name instance. So we have an API and an instance that we want to register. For that API, we want to register that instance, which basically means that I'm going to put this into a bin. So we have a bin where I want to place it. The bin that I want to place it in is my registrations at type ID of the API. So this is the bin where I want to place it. Let's provide a name in here, which is optional and set to empty by default. And basically what I want to do to this bin, I want to place the implementation with that name. And actually, this is going to call the auto const void. No, just a void. Registration. This is the registration that I want to assign. So I'm assigning that to that bin. And now I just need to specify the details of the registration. So the object size is going to be the size of the instance that I want to register. And then we're going to have the constructor. This is going to be a lambda. of a void pointer. That's gonna be marshaled in here. And what I am gonna do in here is I'm just gonna do placement new. So new. Yeah, how did placement new work? That's a good idea. Was it object? Then it was like instance, and it was something like that. This is placement new, but it can't work with O. So we need to have a instance pointer cast to that. Instance pointer casted from that void O object. Then we have the detour, which is basically just a cast and then a call to the destructor. And then we have kind of like our default detour in here registered, which is of course nice. However, I do want to be able to provide custom ones, which is not a big deal. We're just going to copy and paste these. The only thing we could maybe add a bit of aliasing quite quickly. Type name API, type name instance. Void, it's actually not a void. Now I actually want to have a IoC registration reference insert so that we are, or let's call this one just set. Set gets the name. And what Z does is basically that. And then return the registration. And I am basically gonna just set for the name. And then I can specify all the subsequent details. And now I can basically provide multiple of these functions. I now want to provide a destructor. It's going to be an SCD function. I don't know if this is a good idea. If an SCD function, how are they with lifetime? Because I might now get lifetime problems because I need to store them somewhere if I have this SCD function in here. No, we're not going to provide an SCD function in here. We are going to provide function pointer in here. But this is now a bit of a problem because I need storage. SCD function requires storage. But I might be able, if I have templates, I might get away with static initialization is bad. Okay, let's quickly keep this away from now. Let's quickly keep them as default constructors. The only thing that might be passed to the constructor later on is maybe a IoC context. Maybe we're gonna later on have an IoC context that passed into the constructor, and you always need to be able to accept IoC context. This is probably how it's gonna work, so that we kind of like have a context that describes a few informations. But for now, I think this is a good idea how we are doing it. Let's quickly get rid of this stuff. Or actually, let's keep it. Let's keep it for now. We're gonna later on replace it. Let's include that and see if we can work with that. So BL2D common IoC registrations. It is currently not a singleton, but we're gonna make it in the next video, I think, because I'm already nearly over budget of my videos, how I intended to make them from a length. But yeah, let's quickly do a IoC registrations, IoC container. It's not a container, IoC regs or RGS. I know, give them any bad name. And the idea is that I basically can register now my API and my implementation. BL2D dummy iDummy is my API. BL2D dummy is the implementation they want to register. And then basically what I can say is I gotta say auto reference or const auto reference info equals RGS lookup, and now I want to look up the interface. And I shall get some information of the implementation, how this works. So let's run that and see if it compiles even. No, it doesn't compile. It's amazing. registration identifier not found. Okay, auto reference registration. There we go. Okay, issues. BFD registration set, no matching overload found, because we need to give it the template arguments. It's actually not an instance, it's actually the implementation, but it's kind of like an API instance, so it's kind of good. Okay, so RGS, if I now take a look at the RGS, you can see that I have for RTTI type descriptor iDummy, and then I have a second list, and I have an mTOR object which has a size of 8, a CTOR and a DTOR in here. And if I take a look at the RGS that I got, oh, this was already the... Oh, no. The info. The info is actually what we're looking at. We have the size, we have the CTOR, and we have the DTOR. And what we can now even try to do is we can even try to construct the object out of that, even though we don't have that. Let's maybe do a malloc quickly. Let's do a malloc of info dot... Come on. Why do I not get informations? What? What? I know. Let's quickly auto pointer 0. Right, this works, but why do I not get IntelliSense for my info? Oh, damn. Bullshit. Object size is how it's called, and then I have CTOR and DTOR. It's a pointer. Okay. Okay, fine. I thought about doing it as a reference, but if it doesn't match, it's of course a pointer, right? That's correct. Oh, I was a bit concerned about that's why it's not working, but that's okay. Okay, so how do I now can run the CTOR? So now it's CTOR, and the CTOR gets the myDummy in here, and then now the object shall be constructed correctly. Let's take a look on how the object works and if say hello works. And that's the general idea. So myDummy is an object, and we have detected it correctly, and vector deleting destructor and the dummy say hello also looks good. So if I now continue on, I should get in the console my hello world that has been correctly printed. Can see that lookup worked, and yeah, you kind of like constructed our object out of the meta information. And now the only thing that we now need to do is a bit of the management of the lifetime of the object so that inversion of control works and automatic registrations and stuff. So probably in the next video what we're going to do is we're going to implement an IoC stack based on the IoC registration. And then we maybe also gonna start with on getting a bit more proper arguments in the constructor in there with like the IoC context so that we can recursively continue on there. So that seems like a good plan. Next video we're gonna do the IoC stack so that we are not needing to do all of that manual lookup stuff, so that we can basically directly request objects. So basically this is currently the object's construction. We're gonna move that to an IoC stack and make the ability to change stacks together. That's the general idea that we want to do. Alright then, thank you for watching, see you in the next video, make sure to like and subscribe, and have a nice day. Bye!